Hi everyone, welcome to VLSI Explore with Raman. Today we'll discuss events in System Verilog. Before understanding the implementation code of the System Verilog events, let's understand why it's needed. Events can be useful when there is need of the coordination between the two components or two processes at the time you can use this one. Okay. Let's consider you wanted to drive the data to the particular DUT. You have a two task, which is the task one and a task two. Now task one need to be complete, then you have to start the task two. How you can notify task one is completed, then you have to start the task two? By using the system log events, you can do this one. Triggering an event, which means the task one is started. But how you can indicate it by using the triggering event. You can use this arrow operator to trigger the event. When you triggering happen, it behaves like one start behavior, which means it is actually one pass behavior. Okay, it is block the data until the completion of the task. Okay. Let's consider without blocking. If you don't need to block the statement execution, how you can do by using the non-blocking event triggering, you can use this one. Okay, by using this non-blocking operator, you can execute the statement without blocking. It can be executed in the bare area. Now you have triggered the event, you have to wait until the completion, which is the trigger happened, then you have to task is completed, then you have to wait. Okay, how you can wait by using the at the rate operator and wait constructor. Wait is a level trigger. Okay, it can catch the event in the current simulation time and also future simulation time also. But at the rate operator can catch the event triggered in the future simulation time only. Okay, now write a code for it. Let understand easily. Model EP. Let declare event E1. How two processes. Is it process one? Process, process two. All right. Listen. Now you have to trigger process one. Okay. By using this arrow operator, process two need to wait until the process one complete. Process two, you have to use a rate operator to wait the event. Yeah. Here you can see I have declared two processes, which is the process one and the process two. Okay. Now if the process one is completed, then you have to start the process two. Here you can see I'm triggering the event. I'm waiting for the event trigger. Okay. It's waiting operation. This one or the rate operator is waiting for the event trigger. Okay. Yes. Here I'm using some delay 10 nanoseconds. Here you can see the triggering happens 10 nanoseconds after that. Okay. But here the waiting happen at the zero simulation time only. You have to be it's waiting first after that the triggering happen. Okay. Just run the code. Here you can see the output. Process one is started. Okay. This is the zero simulation time. The process one is started. Okay. After 10 nanoseconds, this is the task. Okay. I have triggered here. Process one is completed 10 nanoseconds. But here you can see the zero simulation process two wait until the process one is complete. Okay. Here have triggered after 10 nanoseconds. Okay. After 10 nanoseconds, it will trigger. Triggering happen, but waiting happen at the zero simulation time only. You have to wait until the process which is you have to trigger the event. Okay. You have to wait. Now let's change here. Both which is the process one and the process two waiting same time only. How you can here you can see. I am triggering the happen at 10 nanoseconds and waiting for the event also happen at the 10 nanoseconds. Let's check what is the output here. Here you can see process one is started also of 10 nanoseconds. Process one is completed after 10 nanoseconds. Wait until the process one also this info is printed, but the process two is completed. No, it's not completed. Why here? Here you can see at the same time, which is the 10 nanoseconds have triggered first. First triggering happen, then I am waiting. You have to be wait first, then you have to trigger the event. Okay. Here, but how you can overcome this issue by using the non-blocking operator. Okay. Here you can see when you use this non-blocking operator, it will execute in the NB region. Okay. Here you can see all the tasks, which is the process two is completed and process one also completed. For the non-blocking operator, you can resolve this issue. Here you can see at the same time only what will happen. I am triggering happen at the same time only I'm checking, waiting for the event to happen. Okay. At the time you can use the non-blocking operator, it will execute the statements here. Now let's check with respect to wait here. Wait. Wait is a level trigger. You have to be used triggered keyword. Here you can see it behaves like same as the previous one. All the process one is completed and process two also completed here. Okay. If you can use arrow operator only, let's check what is the output. Yeah, it is same as previous one. Okay. What is the difference between the wait and earth rate operator? Here, see here, earth rate operator. Here I am triggering the event. I am waiting for the event. Okay. Let's run. What is the output? Here, process two is not completed. It's waiting happen, but the process two is not completed. But process one is completed. Then you have to start the process two now. But that does not happen because at the rate operator only check or the future simulation only. It is not check the current simulation time. Okay. If you use the wait statement, wait constructor, it will you can check here. Process two also it will complete here. Okay. You can see process two also complete. It will check current simulation time also, future simulation time also. But if you wanted to use the other rate operator means it will only check the future simulation time only. Okay, it will not check the current simulation time. Okay. If you like the content, please share and subscribe.